All right. The reaction of ammonium nitrate, solid, dissolving water, has a change in enthalpy of 25.7 kilojoules per mole. What is the final temperature in a squeezed cold pack that contains 48 grams of ammonium nitrate dissolved in 125 milliliters of water? Assume the specific heat of 4.18 joules per gram for the solution and the initial temperature of 30 degrees Celsius. Alright, this is basically a calorimetry problem, and we always start off calorimetry problems with our first law of thermodynamics that says the change in the energy of the universe is equal to 0. So what processes do we have here? We have our dissolving, our heat flow to dissolving, plus we have our heat flow of our solution cooling down. Well, each of those are going to be calculated separately. The heat flow due to dissolving is going to be based on our reaction. And we know that for every 1 mole of ammonium nitrate we have, it produces 25.7 kilojoules. Sorry, I was meant to go symbolic there. Let me go symbolic first. Then we have our solution. Our solution is simply heating or cooling. Crap, I can't remember the formula for that. Alright, now we plug and chug. Well, first of all, we don't have a number of moles directly, so we're going to have to calculate that. We're told that we have 48 grams of our ammonium nitrate, and that 48 grams is going to be how many moles? We'll place grams where they cancel out, place moles where they'll be left, and we go to our periodic chart to figure out the molar mass of ammonia, and that is 28, 32, 32, 64, turns out to be 80.04 grams. So if you look what we've done, we've canceled out our grams of ammonia and we have moles of our ammonia. Then we want to multiply by our change in enthalpy. Whoops, wrong color. Or 25.7 kilojoules. That came from our problem up here. So this right here is that term. Alright, now we have to deal with our second term here. We want to deal with our, we want to deal with this term. So we add that, and that's our mass. And here's the place where most people get it wrong. We have a mass not only of our solution, right? We have 125 grams of water, but our total mass of solution includes 48 grams of our ammonium nitrate. And I think that if you got this problem wrong, that's the most likely spot you get it wrong. Because they are telling you to assume that the mass of this, they're telling you to assume that the specific heat of the solution is 4.18 joules. That means you definitely have to include that ammonia there as part of the mass of your overall solution. Now they've told you the specific heat is 4.18. joules, grams, degrees Celsius. And then you have to do your change in temperature. And your change of temperature is always temperature final minus temperature initial. And they tell you that you have an initial temperature of 30 degrees. And they want to know the final temperature. So temperature final minus 30 degrees. And now it becomes one big algebra problem. Alright, I'm going to simplify the part in blue first. Punching it into my calculator. I have 48 divided by 80.04 times 25.7 kilojoules. Remember, units are always a nightmare when you're working problems like this. We're going to have to watch the fact that that's kilojoules. Now I'm going to solve for that term. Or I can't solve for it, but I'm going to simplify it. I have 125 plus 48 times 4.18 joules per gram. So when I do that, I get 723.14 joules per degree Celsius, because my grams have canceled out. And remember, you have to add those. Remember, you have to add these two terms before you can multiply by that one. And we haven't been able to do anything with our TF yet. Next thing we're going to do is distribute. But before we distribute, I want to deal with our unit problem. We've got kilojoules here. We have joules per degree Celsius here. So I'm going to do a quick unit conversion. And I'm going to convert my joules to kilojoules. So 72.314 joules per degree Celsius times 1,000 joules, that's 1,000 per 1 kilojoule. And now my equation reads and I'm carrying way too many sig figs here. Really, I only have 3, so that 1,4 there is insignificant. And I now have kilojoules per degree Celsius. If you got a problem wrong, is forgetting to reconcile these kilojoules and joules that are the next problem. A lot of students have. So let's keep going with our algebra here. Next thing I'm going to do is I'm going to distribute that. So let's distribute. And by distributing, I'm going to multiply 30 times that. So, and that's going to give me a huge number here. That's going to give me 2, 1, oh, whoops, I forgot to. That's going to give me 21.6942, but 3 of those figures are significant, kilojoules per degree Celsius. Oh, whoops, no. My units here, let me erase that whole thing there, that's kind of sloppy. When we distribute, remember that we have 30 degrees Celsius right there. So what's going to happen is when we distribute, that Celsius and that Celsius are going to cancel out, and we're going to be left with 21.69 kilojoules. Now it becomes an algebra exercise. I need to get that term by itself. Well, even before we do that, let's combine. This term and this term have the same unit, so and no variable with them, so let's combine them. So that gives me 6.29 negative, a negative 6.29. And again, I shouldn't be sloppy with my sig figs. As a result of the subtraction, that 9's insignificant. A negative 6.29, there's a negative sign there. Negative 6.29 plus 0.72314 kilojoules degrees Celsius times our variable. And I need to get my temperature by itself, so I move my 6.29 to the other side of the equation, which changes the sign, equals 0.72314 kilojoules per degree Celsius times our final temperature. So we're going to divide both sides by 0.73. And our final temperature equals 6.29 kilojoules divided by 0.72314 kilojoules per degree Celsius. And what happens, the kilojoules cancel out. You have an inverse of a degree Celsius. That brings the degree Celsius up top. And that gives you a final temperature of 8.7. Quick note there, they, I believe, and well, there's no doubt about it, they were sloppy with their sig figs doing this problem. I was not. I stand by my significant figures. I stand by my sig figs. It should be 2. They actually say it's 3 if you do the answer key there. And I believe that they are in error, and I stand by my sig figs there. And that's that.